Okay. Elizabeth, you warned me already, so we'll start with you. Sound okay? Yeah. So 23 reads, Danny is riding his bike that has 22-inch diameter wheels. If he can ride the bike at 14 miles per hour, how many revolutions per minute are his tires making? So I'm going to just kind of treat this as a unit conversions problem. So I have been given this one rate of 14 miles per hour, and I need to convert it into the second rate of revolutions per minute. So I have miles per hour I can write as 14 miles over 1 hour. And I want to end up in revolutions per minute. So the first thing I'm going to do is I'm going to convert hours to minutes. And remember, when you're doing a unit conversion, the unit should always be on a diagonal from each other, right? You remember that from your chemistry or physics or science class of some sort? Okay, that's good. So now we'll be in minutes, so we have the per minute part. What we need to, though, come up with is a way to convert this linear distance of miles into this idea of revolutions. So what relationship does a revolution have to a linear distance? Well, I know that one revolution is equal to one circumference. So if you think about a tire, if you move one revolution, that's going to move one circle of the tire, because every spot on that tire is going to be on the ground at some point before it gets back to its original spot as it rolls. Does that make sense? So in our case, that one circumference is the diameter times pi. And since the diameter is in inches, our revolution is in inches. So in order for me to apply that unit conversion, though, my distance is in miles. I'm going to convert miles to inches. And then after that, I can use this ratio between one revolution to 22 pi inches. Is that okay? All right. So I know that 1 mile is 5,280 feet. And I know that 1 foot is 12 inches. And then I know that 22 pi inches is 1 revolution. So if I look here, hours will cancel, miles will cancel, feet will cancel, inches will cancel, and I'm left with revolutions per minute. So all I'm left to do is to plug that stuff into my calculator to get my answer. Do you mind if I stop there, Elizabeth, and leave it with you guys can punch that stuff in your calculator? I trust. Cool? Okay. Josh, did I see your hand was up earlier?
Yeah.
55? Sure. So 55 asks us to find the exact value using the unit circle. So sine of 135, I guess, degrees. So I'm going to go out and take out my unit circle, which you might have noticed I put in the content library for you guys. So what I'm going to do is I'm going to locate 135 degrees, which is right here. So the x-coordinate there is negative square root 2 over 2, and the y-coordinate is square root 2 over 2. I know in a unit circle situation, the y-coordinate is sine, So I'm just going to write down square root 2 over 2. So it's just reading it off the unit circle is all I needed to do. Is that okay? Well, secant is related to cosine. Secant is 1 over x. So you just take the x coordinate and take the reciprocal. Is that okay? So the same idea if you have like tangent or cotangent, it's like those are y over x or x over y respectively, so you just divide the two fractions. Is that okay? Jason Stewart. Yes. Yeah. Sure thing. So 52 is tan of 7 pi over 6. And it says to find the exact value using a reference triangle. So the first thing I'm going to do is draw a picture of this angle 7 pi over 6. Now the easiest way to do that, well, I shouldn't say easiest. What I'm going to do to show you guys how to do this is I'm not going to convert this to degrees. It's fine if you want to do that, but I think it's important we also start getting used to seeing things in radians and getting comfortable there. So I'm going to kind of talk through how I do that in my head, just so you can kind of see what it is that I'm doing without having to convert it to degrees, which you could do, and there's nothing wrong with doing that. But I want to start developing some of our radian skills also. So the way I'm going to think about this is 7 pi over 6 is basically, I'm going to look at the fraction 7/6 and think about that as a mixed number. So 7/6 is 1 1/6. So I'm going to think about 7 pi over 6 as 1 pi plus pi over 6. Is everybody okay with that idea? It's basically 7/6 is 1 1/6. 7 pi over 6 is 1 pi and then 1 pi over 6, right? So I'm going to draw that angle of pi plus pi over 6. So if I remember, we said that pi over 2 is basically 90 degrees. So we have pi and then pi over 6 more would be this angle here. Okay with that so far? Very important you're able to get that angle in the correct quadrant. Makes a big, big difference. So I'll make my reference triangle now. When I make my reference triangle, I'm always drawing my reference triangle back to the x-axis. It's critically important that you do that. You cannot draw it to the y-axis. You have to draw it back to the x. And then what I'm going to need to do is figure out what this angle is right here. I'm going to call this angle, well, I guess we haven't had a theta yet, so I'll call it theta. So if you think about it for a moment, it shouldn't be too hard to see that this angle is pi over 6, right? And I know that pi over 6 is really the same thing as 30 degrees. So the triangle that I've drawn there in blue is a 30, 60, 90 triangle. So I'm just going to add in the side lengths now for my 30, 60, 90 triangle. Now, normally when I do this, I use x, but I don't want to use x here because we have x and y coordinates going on. So I'm just going to choose a different letter. I'm going to use a in my side length ratios because I know I haven't used an a yet. So I have a root 3, 2a, and this one I'm going to call negative a. Why would I call this one negative? Well, we're in the third quadrant, and that side length is describing the y coordinate in the third quadrant, so I need to make sure I write that as a negative. Oh, likewise, I need to write a negative for my x coordinate also. Jeepers creepers, almost forgot. Jason, are you happy with that? And now I can just use that blue triangle and my right triangle definition for tangent to do opposite over adjacent. So that reduces down to 1 over root 3. And when I rationalize my denominators, I have root 3 over 3. Is that okay? Now, it's really important that you draw the picture, because the only way to determine that you need negative signs on some of these side lengths is by the location of that angle on the xy axis. So you have to be able to get that angle in the right spot and figure out what theta is there. And that's probably easiest by drawing the picture. You happy with that one? Okay. Who wants to go next? Is it Haley? Yes. Yes. Sure. Okay. So it says if an angle falls within the given interval, determine whether sine theta, cosine theta, and tangent theta will be negative or positive. Okay. So I'm going to draw myself a picture here. So 0, 90 degrees, 180 degrees. So the location of my angle that I'm talking about, its terminal side is going to be in this quadrant, right? So in this quadrant, I know the x-coordinate is negative, but the y-coordinate is positive. Well, I know sine theta is related to the y value, which in this case is going to be positive, so sine is positive. Cosine theta is related to the x-coordinate, which is negative, so cosine should be negative. And tangent theta is y over x. Well, the y-coordinate is positive here, but the x-coordinate is going to be negative. Well, I know that positive over negative is negative, so the tangent should be negative there. Does that feel okay? Yeah, no problem. Again, drawing a picture and kind of visualizing what's happening really is helpful here, right? Makes these problems much, much easier to understand what to do and what's going on and whether the assumption we're making is correct or not if you have a visual to kind of look at, because the location of these angles really matters a lot to us. Kristen. 32? Certainly. So 32 says find the exact value without using your calculator. And the angle in question is tan of 45. Well, since that's an acute angle, I can just draw a right triangle with an angle of 45 degrees in it. If that angle is 45, I know this angle is also 45, so what I have is a 45, 45, 90 triangle. The ratio of side lengths for a 45, 45, 90 triangle are x, x, and then the hypotenuse is x square root 2. So the tangent here is opposite over adjacent, which is x over x, which reduces to 1. You're welcome. Again, remembering the ratio of side lengths here is going to be important for you. That's something you'd want to have memorized. At some point, I'm sure you did in your geometry class, but it's been a couple of years, so you may need to refresh those, and that's okay. Who's next? Happy to continue doing more. Josh? 57? Sure. So 57 asks us to find the exact value using our unit circle. So that's cotangent of 330. I'm going to remember that cotangent here is adjacent over opposite, or x over y. So now I'm going to switch over and go to my unit circle and look at the x and y coordinates where they're at a 330 degree angle. So at 330, the x-coordinate is root 3 over 2, and the y-coordinate is negative 1/2. So I have root 3 over 2 over negative 1/2. And then to simplify this, dividing by a fraction is the same thing as multiplying by the reciprocal. So the 2's can cancel out, and I'm left with just negative square root 3. Yes, tangent is y over x. What is that? Abby?
Yeah, is there going to be a unit circle?
Yes. Yeah, I will never, for the entire course, ask you to memorize the unit circle. You'll always be given that tool. So regardless of the chapter, it'll be on every single test from here on out. Because it's, while helpful if you have it memorized, certainly that's a lot of time to devote to doing something that you can always look it up. And just as an FYI, even if you're interested in it, I have put the unit circle on the content library and also put a blank version. Remember when we filled this out in class? If you wanted to redo that activity yourself to get a better understanding of like what's going on there, I put a blank version that you could use yourself to fill out if you cared to do that. You don't have to. It's not an assignment. But, you know, if you've followed along with that and you're like, I'm not sure I got how we're building this thing out and I think that's important and would really help me, I have that there for you to play around with if you want to. Okay? Others. Again, you feel free to ask more than one question. There's no limit. Jason? 60? Sure. It says find secant theta and cotangent theta if sine theta is equal to negative 1/4 and cosine theta is negative. So I'm going to start by drawing a picture to try to figure out what quadrant this angle theta is located in. So I know that sine is related to the y-coordinate and cosine is related to the x-coordinate. So the place where the y-coordinate is negative is in quadrant 3 or 4. And the place where the x-coordinate is negative is in quadrants 2 and 3. The only place where both of them are negative is quadrant 4. So I know that theta is located in quadrant 4. Does that feel okay, Jason? So I'm going to go ahead and draw my angle here in quadrant 4. So there's my theta. I'm sorry, quadrant 3. Yes. My mistake. Yes, I said the wrong word there. Thank you. If you catch me making mistakes, I appreciate when you speak up and let everybody know that I made a mistake. Helps everybody faster if you think I made a mistake. Even if you were wrong and I didn't make a mistake and you think I did, please speak up. And it might just mean that we need to clarify something because I didn't do a good job. But I'm happy to stop and restate something or re-explain something. Keaton. So this was one of our set of definitions. So sine theta is equal to like y over r. Cosine theta was x over r. Tangent theta was y over x, etc. But in this situation, we're on the unit circle. R is 1. So these just simplify down to x and y. And that's something that, again, would not be given to you. That's something I'd expect that you guys have memorized, is that angle of rotation definition of sine, cosine, and tangent that we just cooked up, or that we cooked up the other day. Okay, back to 60 here. So I figured out the quadrant that my angle lies in. So now I'm going to draw my reference triangle. Always draw our reference triangle back to the x-axis. So this guy right here I'm going to call angle phi, just to differentiate it from the angle theta, because it is a different angle measure. But it's going to, the sine, cosine, tangent, etc. of this angle phi is going to be the same as for angle theta. So I'm going to fill in the side lengths because I know that sine is negative 1/4. I know the opposite side is negative 1, and the hypotenuse is positive 4. Remember, the hypotenuse is r, so it's always a length. It's always positive. So the negative sign must be attached to the opposite side because the opposite and adjacent sides are the ones that can be negative or positive. Yes, Jason? Yes, exactly right. Yep. And in fact, I don't even care what that angle measure for that phi is because I don't need it to answer the question. So I'm just going to give it a name just to have a name for it, but it doesn't even need a name because it doesn't even matter. Yep. Good question. Now I need to find this third side of my triangle. To do that, I'm just going to use the Pythagorean theorem. And note that since we're in the third quadrant, this side should also be negative. When I do the Pythagorean theorem, I get the square root of 15. So 1 squared plus b squared equals 4 squared. Solve for b, I get square root of 15. Now I have everything I need. So secant is adjacent over hypotenuse. I'm sorry, hypotenuse over adjacent. And when I rationalize the denominator, I get negative 4 root 15 over 15. Is that okay? And then cotangent is adjacent over opposite, or just positive root 15. Josh. I just put the negative sign could go anywhere. I mean, it's, you know, it's a fraction, so you can put it wherever you want. Yep, no big deal. Good question. Again, that was a little bit lazy on my part, but certainly the 4 is not negative in the picture, and to see the negative sign on the 4, not unreasonable to ask a question about. Anybody else? Elizabeth? So we're going to finish up with some questions, and I'll be out of here in just a second. What's that? Sure. What do you want to do from the review? .4. This one, question 7. Question 8. Okay, okay, question 8, letter A, you said? Okay, so sine of 11 pi over 3. Okay, so it says find the exact value of this. To do this, I'm going to use the unit circle. But if I go and I look at the unit circle, I don't have 11 pi over 3 anywhere on here, right? Well, since it's asking me for an exact value, even though 11 pi over 3 isn't on the unit circle, something coterminal to that should be on the unit circle. So what I'm going to do is I'm just going to think about this as a mixed number. So 11 pi over 3 is really 3 2/3, or 11 over 3 is really 3 2/3. Are you okay with that? So this is going to be 3 pi plus 2 pi over 3. So I'm going to use that to kind of figure out where I'm at on the unit circle. So 1 pi, 2 pi, 3 pi, and then 2/3 of a pi more is right down here. No, wait a minute. 2/3 of a pi more is here, excuse me. Right? 5 pi over 3 is 1 pi plus 2/3 pi. So this is what I'm going to use right here. So this was sine, so I want the y coordinate. So my answer is negative square root 3 over 2. Alternatively, you could have taken 11 pi over 3 and subtracted 2 pi from it, and that would have also gotten you the 5 pi over 3. So either way of thinking about it, whether you're just doing loops around the unit circle, or you're taking your angle and finding something between 0 and 2 pi, either is fine. Does that feel okay, Elizabeth? Okay. All right. Last call from you guys before I head on out of here. Josh? Mm-hmm. So name a fraction. Okay. So 1 over means the same thing as a reciprocal. So just 1 over a fraction means just take the reciprocal of the fraction. So in this case, it would be that, which simplifies down to just root 2. You'd have to do a little bit of algebra to see that, but the easier way to think about it would just be to think 2 is root 2 times root 2. And then it's easy to see how it reduces down. Yeah. Not obvious way of thinking about it, but certainly effective if you do think about it that way to see the simplification. You could have gotten the same thing by rationalizing the denominator. You would have ended up at the same place. Mm-hmm. Let's talk real quick test format before we go, or before I go. All right. So we have 2 questions where we ask you to convert between radians and degrees. Am I going to give you the conversion factor on how to do that? No. That's something that you should have memorized. So you have one question where you have to, given a sector, calculate the arc length, radius, or angle. I'm not going to tell you which one I'd be looking for. So I'll give you 2 of the 3, and you have to find the third. In order to do that, what do you need? Yeah, you need the arc length formula. So there's 2 versions depending on whether you're working in radians or degrees. You would also need to have that memorized. There'll be one question where you have to solve a right triangle. So you should know your right triangle definitions for sine, cosine, tangent, you know, the SOHCAHTOA. I don't think that was an issue for us. You'll have one question where I ask you to draw some angles of rotation. So like if I asked you to draw a negative 1,000 degree angle, You should be able to do that. We did a couple examples of doing that in class, I think, right? Okay. I have 2 questions where I ask you to find the exact value with the unit circle. You'll be given the unit circle. You'll have one question where you're given a point on the terminal side of an angle, and then I'll ask you to find the 6 trig ratios. And lastly, we'll have one question where we're given a trig ratio and some other info, and ask you to find another. So this was similar to like 59 and 60. I think we asked at least one of those questions here just a moment ago. But that's what I'm talking about are questions like 59 and 60. Elizabeth? Okay. So, oops. Okay. So, while I'm gone, I have just placed the homework quiz into the content library. So if I will resync my computer right now, if you give it 30 seconds or something and then you sync yours, you should see that populate in the content library. You'll copy and paste that out of the content library into your own notebook. You should do the homework quiz on your own. Publish your OneNote file as a PDF. And then there's an assignment in the Dropbox called Homework Quiz 2 or something to that effect, where you'll upload your PDF file into that. And then you're free to work on your reviews or your worksheet for the remainder of our time together in class. Okay?